Hello everyone, this is Nash. In high school physics, if there's a charge and the charge could be denoted as a Q, and I want to discuss the electric field contributed by the charge, the positive charge Q. Let's say if there's a point P and I want to talk about the electric field of the point P and contributed by the positive charge Q and the distances are away from the point P. And the electric field is very simple. It can be easily written down as the K times Q and divided by the distance squared. In high school physics, we can derive the electric field simply by this way. But I want to enhance the level of the electric field problem. So let's imagine if there's a line charge. There's a line charge like this. There's a line charge. They are arranged in a line and uniformly, and the total charge is denoted as the Q, and the total length is L. So what would be the electric field at point P contributed by these line charge? This is what we are going to talk about. So in order to do this, it will be quite useful to apply the calculus. Calculus is your best friend when you are dealing with such complicated problems. But actually, it's not that hard. The reason why I want to share this problem is about helping you to practice the calculus. Okay. In order to do so, I want to find out the electric field at point P contributed by these line charge. The first step is I'm going to divide all this line charge to several parts. I want to find out the segment, and the length of the little segment is denoted as dx. Okay, and the position between the little segment and the point P can be denoted as x. This is the first step. All right, so the total charge is Q and the total length is L, so it is not hard to write down the charge density. I will write it down as the lambda. The charge density is the total charge divided by the length L. This is called the charge density. So the electric field simply generated, contributed by this little segment, can be written as the K times dq. dq is the charge of the little segment and divided by the distance squared, that is the x. So what is dq? Since you have the charge density and the length, the total length of the little segment is dx, so the charge density times the dx will be the dq, right? The dq is the charge density and times the total length, the length of the segment. It's not hard. And the charge density is Q divided by L, and I'll keep simplifying later. Okay, since you have the dE, that is the electric field contributed by the little segment, actually I want to find out the electric field generated by all this line charge, So in this way, I need to sum all of them. You need to imagine there are multiple dx, multiple segment waiting line, and I want to sum all the electric field generated by all the segment. Okay, so the next step is you're going to integrate this dE, so it will turn out to be the electric field generated by all line charge, right? So let's keep simplifying this. So the first step is the dq is actually lambda and times the q divided by L. And all these are constants, so I can move it to the front. So the E, let's check the place. Okay, the E will be the K times dq. dq is lambda dx, lambda is q divided by L. And dx, I'll leave it on the right-hand side because I want to integrate the x to the minus 2. Okay, I want to integrate the x to the minus 2 and dx. Actually, you need to write it, you need to consider the upper and the lower limit because I want to start from the beginning of the line charge and to the end of the line charge. And what is the position for the beginning of the line charge is A. So the downward limit will be evaluated from x equals A and evaluated to all this length. And all this length, you don't need to write a new symbol. All this length is actually the A and plus the length of the line charge, that is L. So it will be evaluated from A to A plus L, right? From A to A plus L. So when you want to integrate the x to the minus 2, you need to imagine a symbol, and we'll try to differentiate this symbol, and it will turn out to be x to the minus 2, right? So now you try to integrate this, you need to imagine there's a term. When you differentiate it, it will turn out to be x to the minus 2. Since in front of it, you can imagine there's a positive 1. But when you try to differentiate it, the minus, what you need to put down a minus down. So in front of it, there should be a minus, right? And when you subtract 1 from this term, it will turn out to be minus 2. So it should be minus 1. So let's just differentiate this term. When you try to differentiate this term, the minus times minus, it turned out to be 1. And subtract 1 from the minus 1, it turned out to be minus 2. So when you integrate this term, it will turn out to be all this written in the blue pen, okay? Actually, it's called chalk. Or let's keep simplifying this. Okay, it would now turn out to be the k times q divided by L, and the times the minus 1 over x to the minus 1, right? Evaluated from A to A plus L. Actually, the negative 1 can help you to switch the upper and downward limit, but actually you can do that in mind. So I will just save the time, and let's keep going. It will be equal to KQ divided by L and times, you plug in A for x, you plug in A plus L for x, but the negative 1 can help you to switch them, so it will be 1 over A and minus 1 over A plus L. We're so close. Okay, let's just finish it. All right, this is how we do it. When you try to find out the electric field generated by some special shape like the line charge, it could even be a plane. In the future, I may try to teach you how to calculate the electric field generated by a plane. So this is how we find out the electric field for point P contributed by a line charge. All right, this is simply helping you to practice the calculus. Thanks for watching, and this is Nash.